development of eyes can be categorized into 4 stages, from simple to complex. Stage 1 is the simplest form. Light falling on just a few photoreceptors allows an animal to sense light and dark. At stage 2, organisms can now tell which direction light is coming from. In stage 3, 2 distinct eyes appear. The first is a cupped eye with more photoreceptors. The second is a compound eye that adds more cups. Both types in stage 3 can produce crude images of objects. In stage 4, the most advanced eyes perform complex visual tasks. Lenses, corneas, and irises focus light on photoreceptors, creating sharp, clear vision. This entire evolution, from simple to complex, could theoretically happen in less than 500,000 years.
Ochii negri, lumina vrut să fur odată, dar ochii negri, cumplit atunci s-au răzbunat.
Îmi plac ochii tăi, m-am îndrăgostit de tine, îmi plac ochii tăi, mă nebunesc. Îmi plac ochii tăi, m-am îndrăgostit de tine, îmi plac ochii tăi, mă nebunesc. Îmi plac ochii tăi.
Cât mi-e dor de ochii tăi, ochii tăi, ochii tăi, ce ard ca 2 văpăi, ochii tăi, ochii tăi. Așa multă lumină și atât de cald.
Însă ochii tăi se vor pierde în noapte, lăsându-mă pe mine în urma lor. Știu că ochii tăi vor fi 2 șoapte și mi-e foarte dor, mi-e tare dor de ei. Vreau să simt căldura ta când noaptea va veni, doar stelele să știe că ai sosit.
The shape of their eye lens rapidly, but it gets more interesting. Birds of prey have an almost binocular-like vision. This is how they can swoop down and pick up a mouse with a precision that will astound you. Eagles can see up to a distance of 1 mile. You might just see a desert. But an eagle can focus on a small lizard out there. Their eyes are like a magnifying glass.
Ochii tăi, ochii tăi, de la tine până la mine, nu mai cer cu ape line. Ochii tăi, ochii tăi.
We humans have 3 different kinds of color detecting cells in our eyes. They're known as cones, whereas dogs only have 2. The cone cells that dogs have are only capable of detecting yellow and blue to ultraviolet light. Each type of cone contains a pigment that is sensitive to a different wavelength of light, so the range of color that an animal could see depends on what combination of pigments they have. Since dogs have fewer cone types, they are not able to see as many colors as we can. Many people believe that dogs see in black and white, but that isn't true. A dog would see a rainbow as light blue, dark yellow, light yellow, white, and very dark blue. Pretty drab.
Some dogs see colour better than others, but if you throw a brightly coloured ball their way, they may only see the shape and not the colour. Dogs are most likely to notice motion from long distance. This is more than 10 to 20 times humans can sense. But this is also why you may wind up chasing them down if they run after a faraway squirrel or a car. Frogs can only see moving objects. They can starve to death if their food doesn't move. Interestingly, they can also focus only on objects that they want to see clearly. They don't have to focus on things they don't need, like shadows or raindrops. And just like cats, they have excellent night vision.
Frogs may even be able to detect color in extremely low light situations where other animals only see shades of gray. Frog eyes are especially interesting to humans since they can actually regenerate certain structures if they've been damaged. Scientists believe that by studying frogs' eyes, they could discover a cure for certain vision problems in humans. Frogs also use their eyes to help them swallow food. After a frog has its prey in its mouth, you will see it retract its eyeballs into its head, actually pushing the food down and letting the frog swallow. Hopefully, scientists do not research this aspect of frog vision any further, because that's really gross. Some animals, like snakes, don't see color at all. Snakes that spend most of their time underground have small, simple eyes that only differentiate between light and dark. Snakes that live above ground and need their vision for hunting prey have very clear vision as well as good depth perception. Certain species of snakes, such as boas and pythons, also have what are called pit organs on their heads, which can see heat sources. So, they essentially have their own pair of built-in infrared goggles. Cows. Cows seem like pretty boring animals, so you'd expect them to pretty much see the way that we do. You would be wrong. This is what cows have tricked you into thinking. Most cows do see limited colors, since they're red-green colorblind. They see mostly gray and black, but also versions of yellow and blue, since unlike humans, they only have 2 color receptions. Cows also have what is known as panoramic vision, meaning that they can see in all directions without having to move their heads.
They have something called a panoramic vision. Interestingly enough, it means they can see the entire world without even turning their heads. So, if you approach a cow, unlike a horse, you can walk right up to them and hand them some food. You might just get a big tongue lick on your hand as a thank you. Mice. Just like cats, mice can also not see the color red well. Mice are also nearsighted. They can only see objects that might be about 2 or 3 feet away. So they use their whiskers to navigate their way around. This is why they're so good at finding their way around in the dark. And much like cows, they can see almost all of the way round them. As humans, we think that animals have the same eyesight as we do, but in reality they don't. And how animals see the world is much different than you might think. For example, horses have their eyes positioned on both sides of their heads. This creates a wide field of vision that allows them to escape predators. But it also gives them a disadvantage. They can't see what's right in front of them. Also, they see fewer colours than humans do. They see the world mainly in yellow, grey and blue colours. Insects' eyes generally consist of thousands of tiny lenses and receptors that collectively produce a wide vision. Insects can see ultraviolet light and see everything in slow motion.
So, why is it so hard to swat a fly? It's because time moves more slowly for our little winged friend. This is what trying to swat a fly looks like to you. But this is what you look like to a fly. Compared to us, flies see the world in slow motion.
Flies could see limited colors, but they have a very broad field of vision and see in a sort of mosaic effect. The reason flies can seemingly almost always escape from whatever you're trying to kill them with isn't because they're psychic, but because they literally see the world in slow motion. They're like Keanu Reeves in The Matrix, except all the time. This was discovered in a study that tested different animals' ability to detect separate flashes of fast flickering light.
Time perception depends on how rapidly an animal's nervous system processes sensory information, and it's measured in hertz. We see things at a rate of 60 hertz, but a common housefly sees things at 250 hertz, taking in over 4 times as much visual information per second. This allows the fly to react much quicker than a human. But why does time perception differ at all? Evolution. Smaller animals tend to perceive time faster than larger ones. A tiny fly needs this ability to escape its many predators. But if you're the length of a basketball court or grow your own armor, you don't need that kind of speed to survive.
By the way, did you know butterflies have the best eyesight in the insect world?
Butterflies see with red, green, blue, UV, and the wideband light from red to purple. This really isn't that much, but like bees, it does enable them to detect pollen, and at the end of the day, that's really all they need. Though they have only 0.04 the visual acuity that we do, meaning that they could barely see something that's 50 centimeters away from them, they could still track down pollen on flowers. You've probably heard of the mantis shrimp because of their famous aquarium glass-shattering punching capability. Well, as if they even needed other superhero-esque abilities, it turns out they also have freakishly good eyesight.
Our eyes have 3 types of photoreceptors for light absorption that allows us to see a full spectrum of colors. The photoreceptors process one of the 3 primary colors, red, blue, and green. But mantis shrimp eyes have 12 different types of color receptors, meaning they see color beyond our wildest dreams. But that's not all. Mantis shrimp are able to see the polarization of light, which is light that is radiating, reflected, scattered, or refracted in different planes of direction. Having more types of light-detecting cells than humans, they can see polarized light with less glare and distortion. With this polarized vision, they can actually see things humans can't. Griv says the mantis shrimp can see the hidden world. In this endoscopy image of a mouse colon, a small camera equipped with Griv's optical sensors shows the cancer tissue in blue, while the healthy tissue shows up as yellow. The polarized imaging can see cancer cells early on, well before the cells are recognizable to the human eye.
We can detect early formation of cancer, where the cancerous cells or tissue is still flat. And it's very difficult to see it using today's technology. Cancer tissue tend to be more disorganized. So when you shine polarized light or you shine light, it will bounce off from this tissue and will become polarized, different than a healthy tissue.
In fact, they have one of the most elaborate eyes of any animal on Earth. As mentioned before, humans have 3 types of cones in their eyes. Mantis shrimp have 16. Mantis shrimp can also tune the sensitivity level of their vision at will to adapt to different environments. Scientists have yet to discover another animal that could do that. Who would have thought that the most intricate visual system on Earth would be attached to this weird shrimp?
Eu te-am iubit, ochii tăi, măi, măi. Eu te-am iubit, ochii tăi, de când erau mititei, măi, măi.
Frumoșnică ochii tăi, mai micuță, mă. Cocuri din deal în vale, urbuțul picări.
Mă înnec în ochii tăi, la 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 lei. Plânge lumea după ei, la 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 lei. Ești un înger pe în ochii tăi, la 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 lei. Plânge lumea după ei, la 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 lei. Ești un înger pe pământ, despre tine cânt și zi și noapte.